Hello everyone. Today we are going to see the continuation of the last lecture, that is type 2 problem, which we are going to solve. So we know that the partial differential equation is nothing but there are two or more independent variables and with one dependent variable, then it is called, and the equation is called partial differential equation. And we have seen three different types of solution. First one is complete solution, a solution which contains as many arbitrary constants as the number of independent variables. So general solution, next one is general solution, a solution which contains many arbitrary functions as the order of the equation. And next one is singular solution. It is nothing but it contains neither arbitrary function nor arbitrary constants. Then it is called singular solution. So in the last lecture we have seen a problem of type 1, that is f of p comma q equal to 0, where p is nothing but dou z by dou x and q is nothing but dou z by dou y. So that will not explicitly seen in our problem, that is the problem will be in the form of pq structure, that is f of p comma q equal to 0. Then we have come across how to find the general solution, then complete solution and singular solution. So first of all, the solution for this type of problem, that is type 1 problem, f of p comma q equal to 0, then its solution is of the form is it equal to ax plus by plus c. Then putting p equal to a and q equal to b in the given equation, we have to find b in terms of a. So then you have to substitute the value of b in the solution, that is z equal to ax plus by plus c. We have to replace b in terms of a so that we will get the complete solution. And after finding the complete solution, we have to go for the general solution by putting c equal to some function of, we are introducing the arbitrary function to find the complete solution. So totally z, we are obtaining z in terms of a. So in the equation we will have z totally in terms of a, we have to, and later partially differentiate z with respect to a, and we will get one equation 0 equal to some a dash some a into x something and plus arbitrary function. So we have to eliminate a from the two equations, we will get the complete solution. Then you have to find the singular solution. We have find out the complete solution, no, that take the complete solution and we have to differentiate partially with respect to a and partially with respect to c. Then if you are differentiating partially differentiating with respect to c, we will get the observed result as 0 equal to 1 structure. So there is no singular solution for the type of the problem f of p comma q equal to 0. So this is what we have seen in the last lecture. In this lecture we are going to see the Clairaut's type, that is the function PDE, the partial differential equation, is of the form z equal to px plus qy plus f of pq. That px plus qy and function of pq either p square plus q square minus 1 or p plus q structure, any of them, function of pq will be any of the form. And the complete solution we can easily find out, it's this type of problem is called Clairaut's type, and we can easily find the complete solution by putting p equal to a and q equal to b. So that easily we can able to find the complete solution for this Clairaut's type, that is f of z equal to px plus qy plus f of p comma q. Then the general solution and singular solution can be found by the previous method. Also, the singular solution exists for these type of problem, this Clairaut's type. Okay, for the last type of problem, there is no singular solution. Yeah, that is f of p comma q equal to 0. There is no singular solution. For this type of problem, singular solution exists and we have to find out. So let us move to the problem. See, they have given that is it equal to px plus qy plus q square, p square plus pq plus q square. We have that this is of the structure is it equal to px plus qy plus f of p comma q. So this is of the Clairaut's type. Hence it is easy to find out the complete solution that replacing p by a and q by b. You will get the complete solution as ax plus by plus a square plus ab plus b square. Okay, and next step, so we have found out the complete solution. Next we have to find out the general solution. How do we obtain the general solution? Put b equal to f of a. Here we have two arbitrary constants, z in terms of two arbitrary constants, and putting b equal to some function of a, that is phi of a, we will get the equation 2 becomes ax plus phi of a into y plus a square plus a into phi of a plus pi of a the whole square. So we are getting z in terms of a, and that is arbitrary constant a and arbitrary function phi of a. So eliminating a between these 2 and 3 equation, that is second and third equation, we will get the general solution. That is easily we can obtain. There is no need to evaluate. Okay, just to stop with this. And next we have to find out the singular solution. How do we obtain the singular solution? Take the complete solution, then you have to differentiate. There we have two arbitrary constants a and b. There we have to differentiate that second equation with respect to a and with respect to b. We will get the equations 4 and 5. Eliminating a and b between these two equations, that is equation 4 and equation 5 and equation 2, we will get the general solution. That is, there will be no arbitrary constants, no arbitrary functions in the singular solution. Then it is called the singular solution. Okay. So let us move to the next problem. So similarly, we have one more problem. Let us see to that. So equation, is it equal to, solve the equation, is it equal to px plus qy plus q by p minus p. So mark this as equation number 1. This is of the form px is it equal to px plus qy plus f of p comma q. Okay. Then immediately it is of the type Clairaut's type. So immediately we can find the complete solution by replacing p by a and q by b. So that the equation solution is, the complete solution is it equal to ax plus by plus b by a minus a. So this is our complete solution. From this, to find the general solution, replace b by phi of a. Then equation 2 becomes 3. Okay, that is it equal to ax plus phi of a into y plus phi of a divided by a minus a. Then eliminating a between 2 and 3 equation, we will get the general solution. Next step, you have to find out the singular solution. How do we find the singular solution? Differentiating partially. We have to take, for finding the singular solution, we have to take the complete solution. That is equation number 2. Differentiating partially with respect to a and partially with respect to b, we will get the equations 4 and 5 respectively. Then from this, we can obtain x in terms of the arbitrary constants. So from 4, that is 5, equation 5 becomes y equal to 1 minus 1 by a. So which implies y equal to 1 by a square or a equal to 1 by a. So then after that equation number 4 becomes b divided by a square will become, so x minus by square minus 1, so that b is obtained from this by, in terms of b we are finding b in terms of x and y, a in terms of y. So substituting all this into the equation of that complete solution 2, we will get z in terms of, that is y z equal to 1 minus x. So substituting all these equations and simplifying, we are getting the singular solution as y z equal to 1 by x, 1 minus x. So here notice that there is no arbitrary functions and arbitrary constants. So this is what the Clairaut's type of problem. So thank you for listening. So work out more problems on that and be practiced. Thank you.